Okay, let's get started on consciousness. Now, if you've witnessed a little bit in your journal, you saw a video on consciousness, and it gave a neuropsychologist's perspective about what they're learning about consciousness, and it may have surprised you some. So what we've touched on would be, and it's in your text, we did a little bit last week, was looking at the early work of Freud and William James, and that where they were considering the conscious mind and the unconscious mind. Now, more recently, the focus has been more on what is consciousness and subconsciousness. Now, consciousness, we can say, are our awarenesses of external events around us and the internal sensations, including the awareness of self, the thoughts about one's own experience. I do something, I can think about it and reflect on it. However, we're still learning what consciousness is. And again, like I mentioned in the journal, that's where the current work is being done by some researchers. And we'll have other theoretical perspectives also trying to understand better about what is consciousness, where does it come from, how does it affect our life, and how does it actually work. So let's explore the chapter on consciousness and on altered states of consciousness. So it was through William James that the stream of consciousness and his concept of stream of consciousness that we can grasp the notion that the mind is a continuous flow of sensation, images, thoughts, feelings. Now the stream of consciousness, just so you can check for yourself, it's just basically a little exercise you can do. Have a piece of paper and a pen and start writing for 5 minutes, anything that enters your mind. Regardless of what it is, don't edit it. And what you're going to find is you have a collection of odds and ends and sods and things that just occurred to you. Why am I doing this? Why do I always get asked to do stuff that I don't want to do? Oh, by the way, you'll just find it's a stream of consciousness is what he was talking about. Now we're going to look at the experiences that can alter consciousness in this particular period. We're going to look at sleep, meditation, hypnosis, and psychoactive drugs. Now, every culture around the world has found ways to induce altered states of consciousness for many purposes. Now, whether it's trance rituals, spiritual possession, religious rites, tribal ceremonies, these can be induced by flooding the senses with repetitive chanting, whirling in circles, burning strong or pungent incenses. This is just part of the experience of human over time, and we've explored consciousness on a very experimental basis. But we're going to take a more scientific and research-based look at it. Now, the first most common altered state we experience is sleeping. It's our circadian rhythm that controls our 24-hour highs and lows of varying degrees of consciousness. Now, for example, going to bed at a certain time is in large part because our body is dropping body temperature as we sleep best in lower temperatures. In waking up is an adrenal gland releasing large doses of hormones to wake us up. Now, what changes do you notice over a 24-hour period? Now, you can see the chart here on your screen. It gives you an idea of the way a typical circadian rhythm influences our 24-hour day. Now, that's not to say we can't influence it. That is to say, there are reasons that this might, or we might be disrupting our circadian rhythms, and we'll get into that a little bit later. But this is the typical response to what our body. Now, this is something that's been done deep in our brain that we can't just override. We can't do so without there being consequences. And we'll look at that as well. Now, there's two types of rhythms that are at play. The ultradian rhythms, these are the biological patterns that occur more than one time a day. Things like hunger, going to the washroom, sleep, appetite, energy, alertness, sleepiness, elimination, temperature, blood pressure, heart rate. These are all part of the ultradian rhythms. The infradian rhythms are more related to secretion of hormones, and most notably for women in their menstrual cycle. And these don't happen more than once a day. Now, a very significant part where your circadian rhythms live is in your suprachiasmatic nucleus, the SCN. Now, this is a pair of tiny structures in the brain's hypothalamus that controls the timing of the circadian rhythms. It's our biological clock. And so this is one of the things to bear in mind within the brain, the closer you get down to the brain stem, the closer you get to the middle of the brain, the older part of the brain that is. So the big convoluted part of the brain you can see on the outside, it's all, filled with wrinkles. That's the newest part of the brain, and that's really what separates us from all other mammals and all other animals. It's what we think with. But all that stuff in the middle, the cerebellum, the hypothalamus, the amygdala, all that is old part of the brain, and so it's been there for a reason, and for a long time for a reason. And part of it is circadian rhythms is what keeps us healthiest. And so when we allow the circadian rhythm to do what it does and we abide by the circadian rhythm, we are at our healthiest. When we circumvent that rhythm is where we can start to have disrupted sleep or disrupted circadian rhythm, which could affect our overall functioning. So let's look at that a little more carefully. So disruptions to the circadian rhythm, there's a lot of things that we can get into, but we're going to highlight 3 of them. Now, let's just pull these up here. These are times when disruption can occur to our circadian rhythm, and we're going to look at these 3. Jet lag, the top right. This is when what affects the circadian rhythm is the sunlight that at different times than our usual schedule. This affects sleep and therefore alertness and functioning. Essentially, trying to be awake when your biological clock is trying to sleep. And if you've ever traveled, from one part of the country to another continent, particularly when you travel through several time zones, you'll understand the concept of jet lag, where your body rhythms are out of sync with where you've landed. And you'll feel sluggish, you'll feel alert when everyone's trying to sleep, and when you're trying to sleep, you feel alert, and when you're trying to be awake, you're not feeling so alert. Shift work is another. Now, this is something you may have already experienced in your life, and you know what this feels like, or you may experience it with given your career choice. And here, we're trying to be alert when our circadian rhythms are shutting down, or we're trying to sleep when they're trying to wake us up. So what can you do to reduce the effects of shift work? Well, the biggest, most important thing you can do is healthy diet and regular exercise can be helpful. However, there isn't an absolute correction way to cope with it. You could move work schedules forward from days, then to work evening shifts, then to work night shifts, and rotate it that way. It would make the adjustments easier. Rotating shifts every 3 weeks lessens the effect on sleep. But researchers have been investigating devices and medication to help, and nothing conclusive as of yet. Now, the third area that some of you might already know about, or some of your career choices will lead you towards see this happen, and it's what's known as sundowners. And it's seen in older patients or older people where they're in early signs of Alzheimer's or they're in dementia. And this is where the person appears to be more active at night. It's as if their circadian rhythm is out of sync. They seem to be docile in the daytime and then active at nighttime, and it's known as sundowners. All right, so let's explore sleep a little bit more. We're going to look at what's known as NREM or REM sleep. Now, there's NREM is non-rapid eye movement, and REM is rapid eye movement. But to begin, there's an internal way of sleeping. This is where your brain sleeps. And you see the difference just between the internal dynamics of non-REM and REM. REM appears more active, and it's because it has REM. And then there's the external, where your body's actually shut down. Your eyes are closed, you're breathing differently, your body temperature is different, and these are the external. Now, rapid eye movement is known as our active sleep. About 20 to 25% of our sleep is in the REM part of the sleep cycle. Our sleep is in a series of sleep cycles of repeated stages that last The complete cycle of stage 1 through to stage 5 lasts about 90 minutes per cycle. That would be one cycle. And then we go back to stage 1 and repeat to stage 5 and repeat again. And including, this is also included in the non-REM stages as well as REM stages, that we have these repeated cycles. Now, it's also important to note, when you feel tired in the morning because you've woke up and you think that having 11 or more hours might be better, the issue isn't the number of hours. What's most important about our sleep cycle is not to interrupt it. That is to say, the reason that we're tired after, say, 7 hours, and we're also tired after 11 hours, is because we've interrupted a sleep cycle. If, in fact, we have a 90-minute sleep cycle, then having increments of 90 minutes would make more sense. 90 minutes, 3 hours, 4.5 hours, 6 hours, so on, would be better than having interrupted sleep cycle. That's why we're tired, not because we didn't get enough sleep. We didn't complete a sleep cycle is the problem. Now, if you look at figure 2 on page 76, it looks at the brainwave patterns during sleep. Now, it's also a bit like that on the top, but it's more accurate when you look at the one in your text. Brainwave patterns are different at each stage. Now, this is suggesting that different functions or activities could be occurring at different stages. If the brain is doing different things at different stages because it's recognized by brain waves, then it could go to stand to reason that there's different activities or different functions occurring at those times. It's not known, but it's hypothesized. Now, over our lifetime, our sleep varies. We don't sleep the same amount all the time. As we get older, we tend to sleep less. In infants, they sleep a lot, so it appears as if it aids in the brain's maturing through sleep, that it's actually beneficial to their brain to be sleeping more, that it's beneficial to the way that the brain develops. And as we know, some people wake up early and are ready to go, pop right out of bed, and bang, there they go, while others hit the snooze a dozen times before dragging themselves out of bed. Now, in research, they call this larks and owls. Larks, they awake early and are ready to go. That's due to the fast way that their body raises its temperature, and it's ready to go. But around 7:30 in the evening, they might start to quieten down and start to get tired and tend to go to bed earlier. Now, owls, on the other hand, their body is slow to wake up. Their body temperature rises slowly, and it tends to be good later into the evening before, feeling ready to sleep. Now, when we miss sleep and go for a day or two without sleep, we will experience what researchers call sleep deprivation. Now, we can have maybe a day or two of no sleep, which obviously includes a reduced amount of REM sleep. This results in difficulty concentrating, attention lapses, general irritability, decreased cognitive functioning, and impaired learning, and what we also we may experience is what are known as microsleeps. These are little dozes for 2 to 3 seconds long. Now, that's a big effect. You may have had that, you may have noticed that yourself if you've ever been awake for that length of time. I have, and I've had those experiences. Now, I was involved in a psychological experiment in university where they tested sleep cycles, and mine was 90 minutes long. So part of what I tried as my own personal experiment was to have 90 minutes of sleep each night for a week to see what would happen. And it was interesting. Wasn't nearly as affected by some of the typical sleep deprivation symptoms. Attention lapses, lack of cognitive functioning, and things like that weren't what I felt, but I felt fatigued because I didn't rest my body. My brain got a cycle of sleep and wasn't interrupted, and that seemed to be adequate. I don't think I could have done that very long. I was having troubles at the end of that week, but that's interesting in terms of how important REM sleep is, how important a cycle of sleep is, and how important sleep is, period. So let's look at dream interpretation. Well, let's look at whether in fact there's any real reason to interpret dreams. Often dreams that we remember are REM dreams, or rapid eye movement dreams. Now remember, if you have someone you sleep with, you could easily just spend the night watching them sleep. And when their eyes seem to be rapidly moving under their eyelids, that's when they're having rapid eye movement. And rapid eye movement is just that. The eyes dart around under the lids rapidly. And that's the most active period of sleep. Again, in university, I was in a lot of experiments. I thought it was fun. And one of them I was in was on dreams. And so they would wake me up when I had rapid eye movement and ask me what I was dreaming. So it's during rapid eye movement time that dreams are most vivid, and the ones we're more likely to remember. They're more story-like, they're emotional, and they're more vivid. So you may only remember a few, and many other people may not remember any at all. I don't typically remember dreams at all, but I know I dream, but I don't remember them. We are more likely to remember the dreams when we are awakened during or just after a dream. Now Freud, he viewed dreams as symbolic representations that needed interpretation. However, this doesn't seem to hold a lot of water as to, why would our bodies and our brains dream that needs somebody else to interpret them? That doesn't make a lot of functional sense to why the brain would do it to benefit you when it needs somebody else to interpret it. But we'll look at some of the other theorists. Cognitive theorists consider the function as a creative exploration, that it's not really meaningful. We might be reviewing things, but it's not really functionally meaningful. There's not a lot you'll pull from that. You can go, aha, that's the discovery I need that'll make me millions of dollars. Now, activation synthesis hypothesis sees dreaming as the brain's attempt to make sense of the random firings of the brain. That perhaps through the night the brain isn't actually doing anything functionally, but it's debriefing, it's deactivating, it's resting, and in doing so it's firing off randomly, and a dream is a way of sort of making sense of those random firings. More recently, brain imaging studies are contradicting this random theory. Instead, they're seeing brain continuity. That's just meaning that certain parts of the brain are active during certain types and forms of sleep, which suggests there's something functional about it, that maybe there is purpose and there is meaning. We just don't know as of yet. So at this point, I wouldn't put a lot of stock in being able to interpret your dreams as having anything more meaningful than just a fun story that you could have enjoyed through the night. It would appear that there's no real clear function for dreams as yet, other than perhaps this benign brain activity with no real meaning. Sorry. So now we're going to touch based on looking at some variations in sleep and sleep disorders. Now, how much sleep do we need? Well, that depends on are we short or long sleepers? That determination reflects how much sleep do we need to physically and cognitively function. The proof is in the pudding. If you're getting enough sleep, you're able to function well and at your best. You think well, you physically are well. There is not a single number that represents how much everyone should have. However, people sometimes have disrupted their sleep. And we're going to look at two categories of disrupted sleep. The parasomnia, this is type of sleep that here the disruption is in sleep where activities that are normally occurring in non-sleep times are now occurring in sleep times, most notably sleep talking and sleep walking. Now, sleep talking, this is not quite what you might think. Now, people who sleep talk are unlikely to respond to your questions or speak in any meaningful sentences, even though you'll hear words that are meaningful individually, but collectively and in a cohesive sentence or thought, not so much. Sleep talking can occur in any stage of sleep and occurs most often in children. It's unknown why sleep talking occurs. It could just be that someone just has a lot of words they want to say and they didn't get them all out in the daytime. I doubt it very much. Now, sleepwalking, this involves a person basically shuffling about, having a blank stare in their face, and it's usually they're not talking. If they're talking, it's very unintelligible. Now, some people who sleepwalk can carry out activities. They can go as far as, making a snack, meandering around the house. People have been even known to get into a car. Now, the only risk to people who are sleepwalking is, getting into danger while sleepwalking, but there's no risk of waking them up. The belief that people who are woken up during sleepwalking will die, just not so. They're likely to be very confused and very disoriented for a bit. They just need to be walked back to bed, and back to sleep they go. Another form of parasomnia is known as sleep terrors, and this most often occurs in children. Begins with a piercing scream, a state of panic. They have increased respiration, pounding heart, and it lasts for about 15 minutes, then followed by falling back to sleep. Most children will grow out of them. A few that experience night terrors into adulthood may indicate more issues with anxiety or other psychological issues. Now, anyone who's had a child who's had night terrors recognize that panic or night terrors makes absolutely good sense. And yes, they do tend to just fall asleep again after about 15 or so minutes. Now, nightmares. These are scary dreams that occur during REM stage of sleep. Remember, they're vivid story-like dreams. They aren't necessarily all going to be good. Sometimes they can be scary. And this can be a reaction to traumatic life experiences, or it can be experienced during times of fever and emotional upheaval. And again, it gives some credence. It tends to lend some support to, well, they must have some meaning to my life if I'm having these dreams that are related to emotional upheaval, but they aren't necessarily directly related. Now, the second group of disruptive sleep are known as dysomnia. Now, these are more debilitating in that they're major debilitating disorders that include sleep apnea, narcolepsy, and insomnia. Now, sleep apnea, this is where a person stops breathing when asleep and must be awake in order to breathe again. Now, of course, that's very debilitating and can be very scary if your partner is someone who experiences this. Not surprisingly, it causes a person to be very tired in the daytime, but also the person tends to be a very loud snorer. Clearly, this is a serious sleep disruption as well as a health risk, because it can even lead to death. Now, surgery or for sleep apnea is an option. Breathing apparatus like the one you're seeing in the image there can be very helpful. Now, narcolepsy is the sudden attack of REM sleep at any time. Now, REM sleep in your sleep time at night is fine. It's normal and it doesn't interrupt with what you're doing, namely sleeping. But having REM sleep to suddenly affect you while you're on your job or in class, of course, does. This can happen in the daytime, it's incurable, and as you can imagine, is quite debilitating. I had a student in my class one time who had narcolepsy, and she brought a pillow with her and put it on her desk because every once in a while, it happened from time to time in class, she would just fall asleep, just right there, and her head would slam into the pillow. You can take medication that minimizes the effect. For some people, that medication has other side effects that are unpleasant. And so it's a very debilitating sleep disorder. And insomnia, you probably are familiarized. This is characterized by difficulty falling asleep or staying asleep. Or it's sleep that is really light, you're restless, and is of poor quality. In the daytime, you're lethargic, you're cognitively not performing at your best, and it quite negatively affects your ability to navigate and do your job. This can be very debilitating, as not getting a good sleep or any sleep has many daytime effects. Okay, so we've really only touched on a bunch of this, and of course research into these areas. If you're doing your project in this area, you'll find lots of information on these topics individually. Next week we're going to explore alternating consciousness through concentration and suggestion. This would mean most notably meditation and hypnosis. We're going to also look at the use of psychoactive drugs as a way of alternating consciousness. All right, everybody. good luck and enjoy your semester. I hope things are going well for you, and we'll see you next week. Bye now.